In the deep silence of the cosmos, where time itself seems to stretch into eternity, a new enigma has entered our solar system, an object that refuses to play by the universe's own rules. It drifts through the dark, serene vacuum between worlds, illuminated by an impossible emerald glow that defies every principle of chemistry and physics we've ever known. Astronomers call it 3I divided by Atlas. But the name gives us no comfort, no clarity, because naming something is not the same as understanding it. From the moment this mysterious body appeared in our telescopes, it seemed to carry with it a quiet defiance, a statement written in the language of light. Nearly every comet we've ever studied behaves in predictable ways. They are fragile relics of creation, frozen reservoirs of ice and dust that awaken when sunlight touches their surfaces. As they warm, they vent streams of gas that push them subtly off course, sometimes drifting thousands of kilometers each day. Yet Atlas is different. It does not wander. It holds its path with eerie precision, deviating by no more than 2 kilometers, as if some invisible hand guides its motion. This alone would make it extraordinary. But its orbit is only the beginning of the mystery. When astronomers turned their instruments toward its luminous form, they expected to find familiar spectral fingerprints, lines of carbon, oxygen, hydrogen, the usual elements that define the breadth of a comet. What they found instead was an impossible contradiction. Atlas burns with a fierce, living green light, the exact color produced when sunlight excites diatomic carbon molecules. Yet there is no carbon to be found. It is as though the glow itself were conjured from the void, a phantom radiance without origin. To those who dedicate their lives to understanding the cosmos, this kind of anomaly is both thrilling and unsettling. Science depends on consistency. We see a pattern, we recognize it, and from that recognition, we build understanding. But every so often, the universe steps beyond our expectations and reminds us how little we truly know. Atlas is that reminder made manifest, a cosmic paradox that turns every telescope into an eye of wonder and confusion. And so, the questions begin. Could it be that there are processes at work we have never before encountered? Could this emerald radiance be born from some exotic chemistry unknown to earthly laboratories, or from physical interactions yet to be discovered? Or is it possible that what we are seeing is not chemistry at all, but something else entirely? Something intentional? The human mind, when faced with mystery, always seeks to draw lines between what it sees and what it knows. But Atlas erases those lines. It is not just a distant traveler from the void. It is a challenge. A puzzle that mocks our equations, our carefully plotted models of gravity and light, and forces us to confront the possibility that we might be missing an entire chapter of the cosmic story. Even now, as it glides silently between the orbits of Mars and Jupiter, scientists across the globe are turning every instrument they can toward it. The Gemini Observatory, the Very Large Telescope in Chile, the orbiting eyes of the James Webb Space Telescope, all of them have captured its shimmering emerald halo, and all of them agree what we are witnessing should not exist. The universe, it seems, has decided to bend its own rules once more. It is tempting to dismiss such anomalies as errors of measurement, as flukes of data. But deep down, every scientist knows that these are the moments that change everything. The moments when the familiar cracks open, revealing something deeper, more profound. Something that could rewrite what we believe about the laws that govern existence itself. Atlas has already begun to whisper to us in the only way the cosmos ever truly speaks. Through mystery, its orbit, its light, its silence. Each is a clue that leads not to answers but to better questions. What drives this stability? Why does it glow in colors it should not possess? And perhaps most haunting of all, where did it come from? For now, all we can do is watch as it drifts ever closer to the sun. The emerald light pulses faintly, steady and pure, like the heartbeat of something alive. It is a sight that humbles even the most seasoned observers, a reminder that the universe is not a solved equation, but a living story still being written. And somewhere within that story, between the starlight and the silence, lies Atlas, an object that dares to defy the very logic that defines reality. We have long believed that the cosmos obeys universal laws, that its clockwork precision is unbreakable, its order eternal. But what if that belief is wrong? What if Atlas is not the exception but the first sign that the universe holds far deeper secrets than we've ever imagined? What if everything we think we know about the rules of the cosmos is only the surface of something far greater, stranger, and infinitely more beautiful? The journey to find those answers begins here, with this silent, emerald wanderer, a cosmic phantom gliding through the dark, carrying with it a question that might change everything we know about existence. Next, when the first spectroscopic readings from 3I divided by Atlas reached the data centers in Hawaii, Chile, and Maryland, the initial reaction was disbelief. The spectral signatures were clear, crisp, and perfectly calibrated. Yet they told a story that made no sense. Normally, when sunlight strikes a comet's surface, it excites molecules like diatomic carbon or cyanogen, producing the familiar green glow that paints the tails of comets across the heavens. But Atlas, shining more vividly than any known comet before it, showed no trace of either. The instruments confirmed it again and again. There was no carbon emission line, no molecular trace of what should have been there. It was a paradox, as elegant as it was impossible. Within weeks, the world's observatories turned their attention toward the Emerald Enigma. The European Southern Observatory dispatched the Very Large Telescope in Paranal, its 4 enormous mirrors aligning like mechanical petals under the desert sky. At the same time, the James Webb Space Telescope trained its infrared sensors upon the strange visitor, capturing spectra at resolutions never before achieved for a moving object of this kind. The data came back consistent across every platform. Atlas defied the expected chemical laws. There were no carbon compounds capable of producing its light. The glow was real, its color measurable and steady, but the cause utterly absent. At first, many suspected a calibration issue, a contamination of the optical pathway, or even a rare quantum interference effect. Yet the results remained stubbornly identical, even when recorded from completely different instruments across thousands of kilometers. The green luminescence persisted. Its signature did not fluctuate with solar wind, radiation, or distance. It was a perfect, unwavering beacon. To scientists who study comets, this kind of stability is unthinkable. Every comet is a volatile creature, its brightness flickering with the rhythm of sunlight and rotation. Atlas, however, behaves with a deliberate steadiness, as though controlled. The emissions do not spike when the object turns toward the sun, nor fade when it drifts into shadow. It radiates with a quiet constancy that mocks the chaos of natural physics. Dr. Sofia Marenko, a planetary chemist at the Max Planck Institute, described her first look at the data as like reading a sentence written in a language we thought we invented. She and her team began modeling alternative pathways, exotic mechanisms that could, in theory, create luminescence without the required carbon molecules. None fit the observations. Some suggested the presence of unknown allotropes of carbon forming under extreme pressures. Others speculated about molecular lattices acting as photonic resonators. But the energy output, measured in joules per second of radiated light, was far too stable, far too clean for any random molecular process. Then came the second anomaly, the object's motion. Astronomers have spent centuries refining the mathematics of orbital dynamics. We can predict the path of comets to within fractions of a degree for centuries ahead. Yet in practice, comets always deviate slightly from these perfect orbits due to outgassing. every plume of vapor is a microthruster, pushing the object unpredictably through space. Even our best models accept this dance of randomness as part of nature. But Atlas refuses to dance. Over a span of 72 days, its deviation from the predicted path was measured at just over 2 kilometers. To a layperson, that may seem trivial, but in cosmic mechanics it is extraordinary, thousands of times more precise than any natural cometary motion ever observed. Its course is so stable that it could pass through a solar storm and emerge untouched, like a needle gliding through a hurricane. When Dr. Leonard White of the Jet Propulsion Laboratory first plotted the trajectory on his screen, he reportedly sat in silence for several minutes before uttering a single word: impossible. Teams began to model potential explanations. Perhaps Atlas was extraordinarily massive, its inertia so immense that no solar radiation could meaningfully alter its course. But radar and photometric measurements contradicted that. Its nucleus, while large at several kilometers across, was not unusual in size or density. Others proposed that Atlas might be rotating in a way that perfectly cancels out the thrust of its own outgassing jets. Yet that too was unlikely. Nature is rarely that symmetrical. Each hypothesis collapsed under scrutiny, leaving behind a vacuum of understanding. The mystery deepened when the James Webb Telescope detected metallic vapors streaming from its core. Nickel, in quantities no comet should ever produce at its current distance from the Sun. Nickel sublimates at temperatures far beyond those present in the region between Mars and Jupiter. To vaporize, it would require a heat source internal to the object, a furnace burning where no furnace should be. The spectral signature of that vapor was sharp, distinct, and consistent over several weeks, implying a continuous process rather than a transient flare. What could produce such a phenomenon? Inside every comet lies a nucleus of ice, rock, and metal, but never one hot enough to turn nickel into gas. Some researchers proposed that Atlas might harbor radioactive isotopes generating heat through decay. Yet the power required to sustain the observed emission would be orders of magnitude higher than any known natural source. That left only one conclusion, one so daring that few dared to state it aloud: that the energy was being generated, not released. When astrophysicist Miguel Hernandez of the Universidad de Chile presented his preliminary findings to the International Astronomical Union, the room fell silent. His equation suggested that if the nickel vapor was indeed sustained, then Atlas was either harnessing solar energy with unprecedented efficiency or producing internal power through a mechanism beyond known thermodynamics. Hernandez did not claim it was artificial, but his final slide contained a single question that hung in the air like static. If not natural, then what? Outside official conferences, speculation ran wild. Was Atlas a fragment of an ancient stellar engine, a relic of a civilization long vanished, or merely a new class of interstellar object forged in conditions we have yet to witness? The scientific community, trained to tread carefully between wonder and proof, divided into camps. Some viewed Atlas as a messenger of new physics, others as a misunderstood phenomenon born from the edges of known chemistry. But all agreed on one thing: it was unlike anything seen before. Parallel studies examined its place of origin. By tracing its orbit backward through time, dynamicists estimated that Atlas had entered our solar system from the direction of the constellation Sagittarius, a region rich with interstellar dust and molecular clouds near the galactic center. It was the same general region from which, nearly 5 decades ago, the famous WOW radio signal had been detected, a narrow band burst that some believed to be of artificial origin. When this correlation emerged, the story of Atlas took on an eerie resonance. Could it be coincidence, or was this object somehow linked to that singular cosmic whisper from 1977? Statistically, the odds of such alignment are astronomically low. The WOW signal was detected at a frequency of 1,420 MHz. the natural emission line of hydrogen, the most universal marker in the cosmos. Any intelligent civilization wishing to announce its presence would almost certainly use that frequency. If Atlas had indeed been traveling from that region at that time, it would have been beyond the reach of any of our instruments to detect it. But the coincidence cannot be ignored. The trajectory points almost precisely to the same celestial coordinates from which the signal originated. Skeptics insist that correlation does not imply causation, and they are right. The universe is vast enough for coincidences to masquerade as meaning. Yet even among the most grounded minds, the idea lingers. What if this is not coincidence at all? What if Atlas had already spoken to us once, through that fleeting radio whisper, long before our telescopes ever saw its glow? This possibility has inspired a new generation of researchers to re-examine the WOW data, to search for subtle modulations or patterns that may have gone unnoticed. If there is even the faintest hint of structure in that signal that matches the periodicity of Atlas's motion or its radiant fluctuations, it could redefine our understanding of cosmic communication. But the deeper story of Atlas lies not only in speculation, it lies in the data, and the data alone continues to defy all known physics. Consider the luminous efficiency of its green glow. The photons emitted per second correspond to an energy conversion rate that should deplete its surface material rapidly, yet the glow persists unchanged. No decay, no dimming, no exhaustion of volatile matter. It's as if the object has an internal reservoir, an endless source of power. Some researchers have likened it to a zero-loss luminescent reactor, something that should exist only in theory. Others have proposed that Atlas may be enveloped by an electromagnetic field of unusual coherence, perhaps a naturally generated plasma envelope that stabilizes its emissions and trajectory. Such fields could, in principle, dampen the effect of solar radiation and create a self-correcting motion. Yet no known natural mechanism could generate such a field spontaneously in a comet-sized body. It would require the kind of ordered charge dynamics we see only in engineered systems, fusion reactors, magnetic containment devices, or the theoretical models of stellar sails. As the debate unfolds, telescopes across the globe continue to feed streams of new data to the international research grid. Machine learning algorithms pour over terabytes of readings, searching for hidden correlations. None emerge. The object's parameters remain stable to the point of impossibility. In one particularly revealing experiment, scientists used polarimetry to analyze how light scatters off Atlas's coma. The results indicated that its particles are aligned along specific axes, suggesting the influence of an external magnetic or electric field. In normal comets, dust and ice particles scatter chaotically. In Atlas, they appear to be organized, synchronized as if following a design. For the broader scientific community, this is both exhilarating and terrifying. It implies not merely an anomaly, but an entirely new class of matter-energy interaction. If confirmed, Atlas could redefine our understanding of plasma physics, molecular bonding, and the very mechanisms by which light and matter exchange energy. It may be evidence of physics operating under principles unknown to Earth. In the midst of this, a more philosophical question arises. What if this emerald wanderer is not an error in nature's code, but a deliberate message embedded within it, a signal not written in radio, but in light itself, a form of communication so vast and elegant that it requires the scale of a comet to convey? The idea sounds poetic, almost absurd. And yet, when the universe defies explanation, poetry sometimes becomes the only language left. Whatever the truth, 3i divided by Atlas stands as a mirror held up to human curiosity. It shows us the limits of our knowledge and the immensity that lies beyond. For centuries, we have mapped the heavens with numbers and laws, certain that everything fits somewhere within the machinery of physics. But now, an emerald light glows in defiance, whispering that perhaps the universe still has secrets too great to be contained by equations. And so, the work continues. Every observatory, every data lab, every scientist staring sleepless at the glow of a monitor waits for the next revelation. Because if Atlas truly is what it appears to be, something beyond our comprehension, then it may not just change our science, it may change our place within the universe itself. Next, to understand the magnitude of what 3I divided by Atlas represents, we must first remember the lineage of the tools and minds that brought us here. Every great revelation in astronomy has been born from patience and perseverance, from men and women who refused to accept that the heavens were silent. In the story of Atlas, there are many such figures, scientists, engineers, and dreamers whose lives became entangled with this emerald mystery. Among them is Dr. Lian Okoye, an astrophysicist from the University of Cape Town. She was among the first to receive the initial spectroscopic readings from Namibia, sent by a small network of amateur astronomers who first glimpsed the green shimmer during that fateful lunar eclipse. Her background was in cometary evolution, not anomalies. But when she saw the data, the missing carbon, the perfect stability of motion, she felt something shift inside her. It was as if nature had written a riddle in green light, she would later say. For months she led her team through sleepless nights, recalibrating equipment, reanalyzing spectra, and cross-checking archives for precedent. There was none. In those long nights, something extraordinary happened within the scientific community. Boundaries dissolved. The data of Atlas traveled from observatories in Hawaii to computing clusters in Tokyo, from the Atacama Desert to the laboratories of MIT. Scientists who had never before collaborated found themselves united by a single question. What is this thing? For once, it was not about funding or competition. It was about wonder, pure and shared, and that may be the greatest legacy Atlas will leave behind. The rekindling of a global spirit of curiosity that transcends institutions and borders. To truly grasp its significance, we must look at its anatomy. Atlas's nucleus, observed under thermal infrared imaging, reveals a surface texture smoother than any known cometary body. Its albedo, or reflectivity, is unusually high, almost metallic in its consistency, suggesting either a crust hardened under extreme heat or an outer shell composed of a substance we have yet to categorize. The coma, that glowing atmosphere surrounding the core, extends in a perfect spherical symmetry, not the asymmetric plume that we see in ordinary comets. It suggests that the emissions, whether vapor or energy, are released evenly across the surface, or perhaps controlled by a process maintaining constant equilibrium. The longer scientists study it, the more Atlas seems less like an accident of nature and more like an orchestration, something built whether by physics or by purpose. Its nickel emissions, initially seen as chemical anomalies, are now being investigated as potential indicators of magnetic confinement or self-sustaining plasma. If proven, this would mean that Atlas generates and stabilizes magnetic fields on a scale far smaller than stars, but far larger than any human-made reactor. The implications stretch beyond astronomy. It would force a rewrite of plasma theory, nuclear chemistry, and even thermodynamics as we understand them. But what truly moves those who study it is not just the science, it is the poetry that radiates from its presence. In its quiet glow, people see reflections of humanity's oldest longing, the desire to reach beyond the known. Every telescope pointed toward it becomes a symbol of that yearning. Every spectrum analyzed, every simulation run in the dim hours of morning, is part of an ancient human tradition, to confront the unknown not with fear, but with curiosity. For Dr. Okoye and her team, the breakthrough came when they realized that Atlas's orbit was resonant, not just stable, but harmonically aligned with several planetary orbits, including those of Jupiter and Earth. It seemed to occupy a precise ratio that allowed it to move effortlessly through gravitational corridors without losing speed or balance. This harmonic alignment is not random. It implies that Atlas navigates a kind of gravitational resonance highway, conserving momentum as if guided by invisible threads woven through space-time. To the scientific community, this discovery is monumental. It suggests that there may exist natural corridors through the solar system, routes of least resistance that future spacecraft could one day exploit. In this sense, Atlas could become our first cosmic navigator, a map written in motion rather than ink. As theories multiply, so too does the awe surrounding its origin. Some trace it back to the Oort cloud, that distant shell of icy bodies at the edge of our solar system, but its composition and trajectory contradict such origins. Others hypothesize it as a fragment from another star system, perhaps a relic of a planetary catastrophe that ejected it into interstellar space. If that is true, then 3I divided by Atlas is not just a visitor. It is a messenger from a forgotten world. And yet, there is another, quieter school of thought forming among physicists and philosophers alike. They suggest that Atlas is not a messenger, but a mirror, that it exists not to answer our questions, but to remind us of our limitations. In its defiance of our equations, it exposes the fragility of our certainties. We have spent centuries building an intellectual architecture to contain the universe, and now one emerald object drifts by to show us that the architecture may be incomplete. Perhaps the laws of physics are not broken, but expanded, waiting for us to catch up. The presence of Atlas has already changed the way humanity looks at the sky. Schools now teach it as an active mystery, not a solved equation. Universities are forming interdisciplinary programs combining astronomy, quantum physics, and philosophy to study the conceptual implications of objects that defy physical law. Artists paint it, composers write music inspired by its silent radiance. It has become more than a comet. It is a cultural event, a phenomenon that unites human imagination with scientific rigor. In one particularly moving account, a young astronomer in Kyoto described watching Atlas through a telescope at dawn. As he stared at the distant point of green light, he realized he was witnessing photons that had traveled across billions of kilometers to reach his eyes. It felt alive, he wrote in his journal. Not alive in a biological sense, but in the sense that it was aware of being watched. Such words echo across observatories worldwide. Atlas, silent and steady, seems to look back. Whether that perception is poetic or profound remains to be seen. But what cannot be denied is the transformation it has sparked. For decades, space exploration has been dominated by technology, machines, probes, algorithms. Atlas reminds us that discovery is not merely the domain of devices, but of wonder. It rekindles something ancient in our species, the impulse to stand beneath the stars and feel both small and infinite at once. There is a growing movement to send a probe toward Atlas, a mission that would take years to prepare. Engineers at the European Space Agency and NASA have proposed designs, fast, lean interceptors capable of catching up with the Emerald Wanderer as it loops near the orbit of Mars. The challenge is immense. Its velocity and orbit are precise, and any intercept must be equally exact. But the potential rewards are immeasurable. A single grain of its material could hold the key to understanding its mystery. The composition of that green glow, the pattern of its stability, the secret of its impossible calm, all could be contained within a fragment smaller than a pebble. Even as plans take shape, the deeper question lingers. What if, when we finally touch Atlas, we find not an answer, but another question? What if its surface reveals no new element, no alien artifact, no hidden engine, only a silence deeper than before? Science has always lived within that paradox. The more we discover, the greater the mystery becomes. And perhaps that is the true purpose of Atlas, to remind us that knowledge is not a destination, but a journey, that each mystery, no matter how profound, leads us not to certainty, but to wonder. In that sense, Atlas is not just an object. It is a philosophy written across the night sky, a testament to curiosity itself. As it drifts closer to the sun, its green light continues to intensify, shimmering like a heartbeat across the darkness. Some say it is growing brighter, as if aware of our gaze, as if responding to our curiosity. Others caution that such anthropomorphism is dangerous, that Atlas is no more conscious than the wind or the tide, yet even they cannot deny the feeling it evokes, that quiet, electric awareness, that perhaps, just perhaps, the universe is watching us back. In centuries to come, whether Atlas proves to be a natural phenomenon or something far more extraordinary, its legacy will endure. It will stand as a reminder of this moment, when humanity once again found itself humbled by the unknown, when equations failed and awe prevailed, when we remembered that the cosmos is not a closed system of laws, but an open invitation to explore. So the story of Three I Divided by Atlas continues, written not in words, but in light, drifting through the great ocean of stars. And as we watch it fade into the sun's embrace, we are left with a truth older than science itself, that curiosity is the force that binds us to the universe, that for every mystery the cosmos reveals, there will always be another waiting beyond it. And somewhere out there, perhaps already on its way toward us, the next Atlas glows unseen in the dark, carrying with it the promise that the story of discovery never truly ends.